Hey, what's going on, guys? Against here. Yesterday I gave a consultation to one of my early subscribers. His name is Andy, and he kickstarted freelancing at Upwork thanks to following my web scraping tutorials. Later on, he grew up to be a solid full-stack web developer, now working in Python with Python and Django in full-time basis. But the consultation revealed the fact that he actually had a lack of a very basic general programming knowledge and concepts, and one of those was pointers. And you might wonder that pointers is some sort of a low-level stuff that only needs to be known by programmers who is coding in C or C++, but actually it's not really that truth. So even if you're coding in Python or JavaScript, you still need to be aware of what the pointers are and how in particular they operate in order to make sure that you understand what in particular you're writing within your source code and how you can make use of those pointers. So this tutorial is going to be dedicated to how to use on how to understand how the pointers work in high-level languages like Python and JavaScript. First, I will demonstrate this stuff in Python and then quickly in JavaScript. The reason for considering Python is because we can bring the physical memory addresses of the variables we're working with, while we can do the same stuff in JavaScript because of the way of how JavaScript is implemented. So if you're interested in following this sort of a tutorial, buckle up and we begin. So I just want to start my Python interpreter here, and a very quick example before we get into the pointers. To get the idea where the confusion comes from. So let's say we create in the number that is equal to 10, and then we create in a simple function, let's call it change, and we're passing this number, and we can say that number is equal to 20, and now we just want to return the number. And now we say new number would be equal to change and pass in this number. Now the question is, what would be the value of number and what would be the value of new number? If you're not aware of this and interested to figure it out on your own, pause the video. For those who already knows, I will definitely let you know the answer as well. So num would be equal still would be equal to 10, while new num would be equal to 20. Let's check this. So number, we have 10, and new number, we have 20. But this sort of a behavior is not going to be repeated in case if we are working with the complicated objects, say dictionaries in Python. So the next example, I'll show you exactly the same example, but with a complicated, more complex data type. So again, like let's exit from here and clear this stuff and start a new Python interactive shell here. And now I just want to create an object that would be equal to, so let's have an array, which is literally the type of Python list. So 1, 2, 3, and also some integer value like 10. And now we want to change, now again, we want to change our, our object. Well, we want to define our change function, and here we're taking object as an argument. But on the real deal, it's not a copy of the object. It's more like a reference, a physical memory address reference of the object. But let me just complete the function first and then break the process down of what has just happened. So if you now just say object, and again, like in this, well, just to give, yes, probably, let's probably give this variable a different name to make sure that we're not referencing the global object. Obviously, we're not, because Python, obviously Python encapsulates the stack, the namespace variables of the within the function scope. But still, let's call it def change, and let's call it object reference, which it literally is in particular. And here we can simply say object reference, and let's take the array, and let's take the very first element and make it equal, so it was 1, let's make it 10. And now let's say object reference and the value, and let's make it equal to 20. and eventually I want to return the object reference like this. And now again, like if you don't know what would it be, well, let's create new object and assign the value returned by the change function, and we're passing our object as an argument. So again, like for those of you who's not aware, what would be the value of object and new object? Now you just pause the video, try to figure out on your own what the value would be. And for those who is aware, I will definitely let you know. In this case, the initial object would get its values changed. So this would be equal to 10 and this one would be equal to 20. And exactly the same stuff would be within this new object. So let me just demonstrate you this. So if you just print the object, then surprisingly, for those of you who's not aware of what pointers are and how they work, we see that the first element has been changed. Well, it didn't happen when we were working with a single numeric value, like in the previous example. And also this value has been changed as well. And if you just print the new object, then we have exactly the same sort of stuff. Now, to bring a little bit of light into this example, to give an idea why in particular this is happening, I would like to introduce the hexadecimal representation of the variable's physical memory location. So if we want to have that physical memory location, we can use this standard Python ID function, which is hard-coded there in the language. So let's see the object, and here we have a physical memory address in hexadecimal where this object kind of lives. And if we just print the same for a new object, we see that we have exactly the same value here. So what happens on the low level when we're calling this sort of a function, this change function? So we exactly pass the object reference. So literally this sort of address is passed as an argument to this change function when we call this sort of a function in this sort of way. And then whatever we do with this object reference, which is literally a memory address, we actually change the values at the memory address. So we're not working with a copy, we're working with a reference. And that's the core idea behind the pointers. So we work, thankfully to the pointers, we can work with the object reference, not with the object copy. So in the previous example, we were working with a copy. And that's the reason why we actually return a new variable back. And here, in particular, we're working with the actual object reference. The object is located right over in here. And also, when we return this object reference, so we still have exactly the same address. So we took this address here, this is here, then we passed it right over in here. Then at this address literally means right over in here. We're just changing the values as if we just said like, so what we've done within the function is equal to, if I just said object array and then the first element, let's set it back to 1, and let's have a look at the object. In this case, you see like it has been restored back to 1. So that's it basically. And exactly the same way, if I just now say the new object equals to object, and I just want to print the new object here, in this case we have this new object being changed without even calling this function. So this is how the pointers work, because by this assigning we simply using this address, we are making this new object variable pointing to this exactly the same address, to this one where the initial object actually points. So in practice, why do we need pointers? We need them if we want to change some sort of objects from the function. That's the practical application of this sort of stuff. And now another little, I don't know how to call it properly, probably concept. I don't know whether you heard about it or not, but Andy asked me about so-called DEEPCOPY. And despite the fact that we have a standard deep copy library in Python, which used to actually create a deep copies of the entire class object instances. But I'll try now to demonstrate. I will now demonstrate a less sophisticated way, and just trying to show the easiest way of how we can make a deep copy of this like object. So the idea is a very simple. So what if we want to create a function that takes this object, but after change we want to retrieve a new object with the new values, but we don't really want to the original object to be changed. Okay, so that is how we can that's the exact place where we can, that's the exact scenario where we can use the deep copy. So by saying deep copy, I mean creating a new object instance and not using the reference, not using this shared memory address, but creating a new memory address, and the particular practical technique on how that can be achieved. So let's exit from here and run Python interpreter. I'm sorry, let's clear the screen first and run Python interpreter. So in order to achieve our goal, we'll need to have a JSON module, which is the standard Python module. And here, let's go the same. So I'm just creating the object, exactly the same stuff. So here I have array, and it would be 1, 2, 3, and also I have a value which would be equal to 10. Okay, and also creating this def change, and in this case we would like to say it won't be a copy anymore. It would be, well, there are two ways of how one can make a deep copy. So you can make a deep copy first and pass the reference to your deep copy into your change method, or alternatively you can create a deep copy within your change method, and probably we'll go for the second method because it's more didactic, probably it's more educative. So here still we have this object reference, okay, but now we're not allowed actually to change this object reference. So let's create a variable called object deep copy, and it would be equal to, well, probably yeah. Okay guys, just before this stuff I just want to demonstrate the process of creating a deep copy in separate. Yeah, so I'm sorry, let's just I just want to show you the process of creating deep copy in separate, and then we'll come back to our example. So deep copy, I just import JSON, and let's say the object, and this sort of an object here. So I have the array, I have 1, 2, 3, and I have the value, and it would be 10. So excuse me, oh, it's not JavaScript, sorry guys, it's not JavaScript. So if I have a look at our object, this is it, and if we have a look at the address, this would be hexadecimal ID of the object, and we have this sort of a value. Okay, now in order to create a deep copy, so first I will break this into steps. So the first step, I'm going to be using JSON dumps and JSON loads function to make that. So first we need to, the first step in order to create a deep copy, we need to convert an object into a string. So first we want to convert an object into a string. So let's say object string would be equal to JSON dot dumps and object. Okay, and if I just bring this object string now, you see like it's already stringified. It's no longer an actual object. So this just to give you an idea, so if we print the type of object, this would be dictionary. Okay, and if we print the type of object string, it would be a string. So I hope this is clear. And now we can create so-called deep copy of an object. Let's say object deep copy, and it would be equal to json.loads, and I'm using my object string here. So if we have a look at our object deep copy, it's still the same, but it would now have a different address from this one. So let's have a look how this works. So again, like hex ID and the object. So the initial object address is this one, and of object deep copy, here we have an absolutely different address. So from now on, if we would be changing our deep copy object, that means that we would be changing the reference, whatever is located at this sort of address, not at this one. I hope that's clear. So this is the exact technique that we're supposed to be doing with within the function. So I just wanted to break this down to make sure that you understand how this stuff works. And again, like, okay, so I would be using the one-liner in order to obtain this. So I can say like object deep copy would be equal to json.loads and whatever returned by json.dumps and object. Okay, and now if we have a look at object and at the deep copy, it's kind of new deep copy, so obviously the address has been changed, but this is how we can create a deep copy in one line of Python code. So I hope this is clear, and now let's go back to our final example showcasing how we can make use of deep copy when we want to return a new object from the function without altering the initial object. So let's go to Python 3 again, and the same stuff. So just create my object back. So the same stuff, array, and 1 2 3, and the value equals to 10, and def change, and this would be, here we'll have the object reference. Okay, and here the very first thing we want to create a deep copy. So let's call it object deep copy, and it would be equal to, okay, I just forgot to import JSON. Oh man. Okay, I just forgot to import JSON. So import JSON, it won't be working otherwise. So object reference. Okay, so object deep copy would be equal to json.loads and json.dumps and the object reference. So here we are not altering the initial object reference, we're just using it to obtain the stringified version of this sort of an object, and then we're creating a new instance of this dictionary in the memory, addressed here at object deep copy. So I hope this is clear. And now in order to change something, we can work with this object deep copy. So I can simply say object deep copy, and let's say again like array, and the very first element would be equal to 10, and object deep copy, let's say the value would be equal to, let's say 22, and finally we want to return object deep copy. Okay, so now we create a new object. So new object would be equal to change, and I'm passing the object reference, literally the address of that, to the function. Okay, and now let's have a look again, like for those of you who has no idea what the result would be, just pause the video, try to guess it on your own, try to understand. For those of you who is aware, I'll obviously let you know that the initial object would remain untouched, while new object would be containing this value. So let's check that out. So if I just print the object, we have it being untouched here. But if we just have a look at the new object, then surprisingly we have, well, it's not a surprise obviously, we have this newly updated kind of like values here. So I hope this is quite pretty clear, and I really hope this makes sense to you. The very last task to consider, we can see the physical memory addresses of both of them. So if we just have a look at the memory address of the object and of the new object, you see like they're different because they reference the different physical memory addresses. So I hope this makes sense to you guys. And now a very quick example of the same stuff but in JavaScript, because it works literally in exactly the same way. So I just want to exit from here and I don't need this anymore. So let's consider if we have a number. Let's create a variable number equal to say 5, and then we say function change, and this we're passing this num here, and we want to say that num is equal to 10, and we want to return num. Okay, and let's say a new num would be equal to, oh man, I just it's the wrong name for a function. Okay, I'm sorry for using e instead of a, but I hope you got the gist. Just don't really want to wasting your time. Okay, new num. And if we have a look at the number, we have it equal to 5, and the new number is now equal to 10. I hope this is clear. So let's clear the console. Sorry. And now let's try what we tried with an object. That would be absolutely the same stuff. So let's say variable I call object like this here, and we'll have the array, and we have 1, 2, 3. And also we have the value equals to 10, and then we have the function change, and this function would be referencing the object, or would be taking the object reference. Okay, and here I just want to say, if we just say object reference, let's say array and index by 0. I hope this notation is still on the cards in JavaScript, equals to 10. And let's say object reference and the value, okay, I'm sorry, the value equals to, let's say, 22, and at the very end we want to return object reference. And I could have called this object as well, doesn't matter how I call this variable, just to give it a more meaningful name, to give an idea of what this is in particular. So I just execute this stuff. Okay, what's sorry guys, so probably I need to say like this, array and dot value. Hold on a second, 3. Oh man, it wasn't that. Function. Okay, yeah, so I think I could have used this notation as well, but doesn't matter. So if we just now create variable new object, and it would be equal to change, and I'm passing the object here. Okay, then if we just now print our object, then just have a look. So it has been changed, so the initial value has been changed to 10 like we did, and this has been changed as well, and the same stuff would be in our new object. So this is exactly the same stuff as we had in Python, so the same stuff but in JavaScript. So by alter. So again, like we are dealing with a actual memory, physical memory address, where that points to where this object lives in a physical memory, and if we are altering it like this, we can't actually obtain this. We do obtain a new. We actually don't obtain anything new. We simply changing the existing variable. So now the very last thing regarding this tutorial, just to give you an idea of how to make a deep copy in JavaScript. Let's go for it. So if I just yeah, probably I can reuse my code here. So here, object reference, the same stuff, but here let's say object deep copy and object deep copy as well, like right over in here. And here, just to create a deep copy, like we use JSON dumps and JSON loads, in JavaScript we can use JSON stringify and JSON parse. So just create this object deep copy that would be equal to JSON dot parse, okay, parse, and whatever is there at JSON dot stringify, and I want to stringify the object reference. Okay, and this is it actually. So now I'll create a new object. So variable, let's say, yeah, new object would be equal to change and this initial object as a reference. So let's have a look at the, so again, if you don't know what would it be in return, just pause the video, try to guess it on your own. For those of you who is aware, I will tell you that object would remain untouched while this new object would be changed to this particular value. So just to demonstrate you this, so if we just print our object, we have the initial values, what we had before, and if we just print this new object, we'll have the altered values respectively. So here we have this values being updated because here we're working with the so-called deep copy. So literally we've created a new memory address, and we've created this from converting this initial object to a string and then parsing it, and this JSON parse actually creates a new memory address for this sort of a deep copy. In this happens implicitly, but I just wanted to show you guys how important this is to understand of, you know, like how important this is to understand what's going on under the hood, basically, this all this low level pointer stuff. So I hope this makes sense to you. And again, like even if you're working with a high level languages like Python or JavaScript, this sort of a knowledge are absolutely essential to make sure that you know exactly the way how your code works. This is it from my side, guys. I hope to see you in the new videos here on Code Makikin's channel. Until next time, and take care.